Alright, so just a quick overview of Michaelis-Menten kinetics. This graph right here is the initial substrate concentration versus the reaction velocity. This is the general equation for enzyme reaction, and then this is the actual Michaelis-Menten equation. As you can see, there's a Vmax and a Km, which are the Michaelis-Menten constants. And the goal of this lab is to determine those. So from your experimental data, you'll be able to see Vmax, and then Km is half Vmax where it hits the x-axis. And then those will be your initial guesses into your nonlinear regression. So in terms of where to take data, Michaelis-Menten has like 3 distinct regions in its curve. This first portion is linear, and out here it's completely flat, and in between there's sort of it curves towards it. So in this first region, this region's important because it helps determine your initial Km. So you want about 4 to 5 data points in this region. This third region is just basically like a flat line, or it should be approximately flat, so it's not very hard to fit. So you really only need 2 or 3 points here. This second region, since we're doing nonlinear regression, this is the hardest region to fit since it has curvature. So you also want 4 to 5 data points in that region. So for the initial rates method, using the well plate, you have 12 wells, minus 1 for the blank. So you can test 11 substrate concentrations at one time. How fast this happens, how fast you go from linear to the plateau, depends on how much enzyme you use. So you want to make sure you're not using too much enzyme, or else you won't see this region at all.